Yeah. So traveling salesman problem, as we have discussed in earlier classes also. Here, a traveling salesman has to start from a place, his hometown, and visit all the other places, and he has to come back. So here in this problem, which I have taken, we will see the multiple solutions also. Suppose he has started from his hometown, which happens to be the place A, and he goes, he must have called to, the solution says that he has to go to C first, then to D, then to E, then to B, and then to back home. Okay. So in that case, what happens is, suppose the person, the manager, yes, manager in a particular location is not available at that time.
What's the chapandi?
Yes. Yes, sir. You want me to be slower, sir?
No, madam. Please mute Ramana sir device, ma'am.
In, sir?
Ramana sir, the mute chain, madam. Otherwise, he is not able to mute.
Okay. Mute change, sir. Atla? Mute change.
Yeah, from your side, you can do it.
Okay, I'll do, sir. Participants, Ramana, so mute. Narayana, sir? Okay.
Yes.
Yes, sir. Okay, close. Okay, sir. So, we will see this, sir. Okay. So, this is the question which is given. Okay. Drop. A, B, C, D, E. These are the locations. So the distance from the place A to B will be put as a dash. Okay, because A to A, you don't have any distance. Okay. So these are typically the distances which are given in the matrix. So this is dash, this is 3, this is 6, 2. You can note down this, please. 3. That's 3. That's not the B. Okay. 5. 2.
Ma'am, excuse me.
Yes, ma'am.
Ma'am, which topic this one?
Traveling salesman problem. Assignment problem.
Okay, ma'am.
Traveling salesman. Okay. So this is a typical case of assignment problem. So that's why I'm doing this. Okay. So till the end, we have to solve it like a assignment problem only, wherein, yeah, 1 minute. This is 6, sorry. 6 dash 6. Okay. 3, 3, 4, 6 dash. See, this is the problem. Okay. So these are the distances. These are the distances which are given. Okay. Yeah. Or the cost, whatever it is. Okay. Cost or the distances are given. Okay. So here in this problem, it is given as cost. Okay. From moving from A to B, you incur 3,000 maybe. Okay. From
traveling costs.
Yeah, these are traveling costs. Okay. A to C, you incur 6,000. A to D, you incur 2,000 or 200 or whatever it is. It is units. Okay. The same units are followed. And A to E, you incur 3. B to A, you incur 3 again. Okay. A to B, B to A will be almost same or most of the times, unless there is some other route. Okay. B to C is 5 and so on. Okay. B to B, you are not incurring anything because moving within that city doesn't cost you much. So now the problem is, we have to find out the solution, something like this. Suppose this traveling salesman's hometown is A. To which place he has to go first? to see, suppose this is a hypothetical solution I'm giving. Okay, this is the solution you have to give us. Okay, we have to find such a solution. Okay, he has to go through all the places, come back to his home. Is that clear? So this sequence we have to find out. So this can be done by assignment problem only. Okay, this can be done by assignment problem. So please note down this. We will be doing the same thing. Is this a balanced problem?
Yes, madam.
Yes. Is it a minimization problem?
Yes.
Yes. So we can go ahead with the row reduction now. Okay, we can go ahead with row reduction. So in row reduction, what do? We try to make at least one number 0. Okay. So in the first row, with what number should I deduct?
2.
Very good, 2. So yeah, tell me. Dash 1,
4,
4,
0, 1.
0, 1. Right. Second row. What is the reducing factor?
2.
2. So 1.
1 dash.
Yeah.
3,
3,
0, 1.
1. Then third
4.
row. Third row 4. Okay.
Yes.
So how much?
2,
1
dash 2, 0.
2, 0. Then fourth row.
2 only.
2. Yes.
0, 0,
0.
4 dash.
Dash 4.
4.
Fifth row.
3, 0, 0,
0, 0,
1, 3 dash.
1, 3 dash. Please, I'm erasing the original matrix. You can always help me with the matrix later. Okay. So is the entire screen visible to everybody?
Yes, madam.
Yeah. So do the column reduction also, please. Okay, start doing the column reduction. First column, does it need reduction? First
No,
column.
not required.
Not required. Second column.
Not required.
Third column.
Yes.
Yes. So only for third column, I think there is a requirement to do column reduction. That's all. Okay. Yes. Okay. So, sorry. Yeah. So you can tell me the numbers. First
Dash.
column.
Dash. Column wise, madam.
Yeah, column wise. 1,
1, 2, 0, 0.
2, 0, 0. Second column.
1 dash.
1 dash.
1, 0, 0.
0, 0. Till the last, please, for traveling. Yeah. Second, third column.
3,
3,
2,
2,
dash.
dash.
3,
3,
0.
0. Fourth column.
0, 0.
0, 0.
2 dash.
2 dash.
3.
3. Then 1,
1, 1, 0.
0, 4 dash. See, this can be used, this dash technique can be used for restricted assignment problem also. I told you in the last class, restricted assignment problem can be where a particular worker is saying that I can't work on that machine. So put a dash there, that's all. Okay, and go ahead with the numerical as it is. Okay, is that clear? So dash should be treated as dash till the last. Okay, so yes. Now all the rows and columns have zeros.
Yes.
Yeah, now our job is to cover all the zeros with minimum possible lines. Okay, if someone is able to do it with 4 lines, if someone is doing it with 5 lines, the person who is doing it with 4 lines is correct. Okay, so first row, is it having single zero?
Yes.
Yes. So cover the zeros with a vertical line. Vertical line. If it is in a row, vertical line. If it is in a column, horizontal line. Okay, then second row is not there. Third row, is it a single zero row?
Yes.
Yeah, if it is in a row, please vertical line. Okay. Then fourth row, fifth row.
No, 2 zeros are there. 2 and
column, second column.
Third column only 1
Third
zero.
column, yes. If it is in the column, draw a horizontal line. Okay. Yeah. Now, anything else?
Now again come to first and second columns.
Yeah, first column. First column is having a single zero. Column, horizontal line. Okay. So by single zero technique, we are not overusing the lines. See, if we would have randomly done it, we would have covered all the zeros with 5 lines. But how many lines are required here? How many
Five.
lines did we? How many lines did we cover all the zeros with?
4.
4 lines.
Did we get the solution?
No.
No. So we have to go ahead. Okay. Which is the least uncovered number? Least uncovered number, please. Least uncovered number. Yeah, least uncovered number.
1.
1. So what we'll do is, yeah, dash will remain dash. From the uncovered numbers, remove that 1. So 1 will become 0. 3 will become 2. Then 1 will become 0 dash 1. Is that clear? From uncovered numbers, we are removing, subtracting 1.
0 dash.
Yeah, covered numbers, please do not disturb them. They are sleeping under a blanket. Okay. Yeah. 0, 1,
2 0
0. Yeah,
dash,
here also 0,
dash,
0,
0
3,
dash,
dash will remain dash.
5
And
5.
4, yeah, very good. 5. This 4 is at a junction. So what we do is we add back. Okay. Then 0, 0, 0.
4.
3 is again junction. 4 dash.
2.
No, dash.
Yeah, dash.
There we had a dash. Dash will remain dash.
Yes.
Okay. Yeah. Again, we'll try covering all the zeros. First row, is it a single zero row? First row, second row, third row, fourth row, fifth row. Any single zero rows we have? No. Any columns we have?
Yes, last column.
Last column. So we will draw a horizontal line here.
Third
Okay.
column also, madam. Third column also we have 1 0.
Third column also we have 1 0. So we'll draw a horizontal line here also. Okay. Anything now has become single zero?
No.
No. See, but our objective is to cover all the zeros. Okay. Our single zero technique will be used to not to use over lines. Too many lines. Okay. But now single zero technique has failed, isn't it? Can you see the location of zeros? There are no single zero rows or columns, isn't it? Yes?
Yes, madam.
Yes. But I have to cover all the zeros. So what do I do now? You tell me. Can I do it? Arbitrarily.
Any of the rows or columns.
Only 2 lines. Can I cover all the zeros, rest of the zeros with 2 lines? Can you tell me? 2 horizontal or vertical or a mix of horizontal and vertical. Can I do it with 2 lines? Is it possible with 2 lines?
No.
No. I need to use 3 lines, isn't it?
Yes.
Yes. So this single zero technique has failed. Means it's an indication that there is more than one solution. Is that clear? Our single zero technique has failed. It means that we have more than one solution. Is that clear?
Yes.
Yes. Okay. So I will erase this part and now we will write the solution. Okay. So till the last, till all the zeros are covered with 5 lines, we have to do it same like assignment problem. Okay. But assigning, we shouldn't do it the same way. Okay. Now we will see how to assign. Okay. We will see how to assign. See, assignment is always done. Preference should be given to 0. Okay. Preference should be given to 0, I said. Okay. Means if suppose 0 isn't possible, I can go for 1 or 2 also. Is that clear? Preference of assignment should be given for 0. Okay. But suppose if So I will rewrite the matrix, removing those lines. Now we will do the assignment. Okay. 0 dash
Dash
1
101
0 1
10 dash
0 dash 2 0. Please don't get disturbed. Be attentive when we are doing this traveling salesman, because you have too many zeros. You have to think of a cycle. Okay. Yeah. Now I'll write down A, B, C, D, E also. For the final assignment, we have to write. Okay. A, B, C, D, E. Now we are assuming that the salesman home is located at A. Okay. From A, where can we go? I'm in A now. From A, where can I go?
B or D.
B or D. Very good. So I will start by randomly taking B. Okay. I will go to B. Okay. Now I am in B now. Okay. Can you see I am in B now? From B, where can I go?
A.
A or D. But can I come back to A?
No.
I started from A. I need to cover rest of the places, so I can't do. Can I go to D?
Yes.
Yes, I will go to D. Okay. So now I am in D. Okay. From D, where can I go? A. Can I go to A?
No.
A, yes. I need to cover rest of the places. No, sir. C, E, I haven't covered. I can't come back to A. Can I go to B?
No.
No. C and E options are very costly. Do you get the point now? So this route I abandon. This route I abandon. Okay, I rule out this one because
Yes.
this is doesn't seem to be a feasible one. Are you getting the point?
Yes.
Yes. So now I will start again.
A to D.
A to D.
D.
Very good. A to D. Then I'm in D now.
D to B.
D to
B.
D to B. Very good. D to B. I'm in B now.
B to not possible.
D to A, I can't come back.
Mm-hmm.
I can't come back to D. But C and E options are little cheaper. Are you getting the point?
Yes.
C and E options are little cheaper. So what do I do? Should I go to C and C? Should I go to C and C? Yes, I will go to C. Okay. I am in C now. From C, where should I go?
C to E.
Very good. C to E is again 0 option. Yeah. C to E. Sorry. C to E. Now I am in E now. From E, can I come back to A?
Yes.
Yes. Are you getting the point? How we did? See, we were in A. We have started by opting out for B. Then from B, we went to D. But from D, we can't come back to A. We can't come back to B. C and E options were little expensive. 3 and 5 were very expensive. Okay, so we ruled out this. Then we tried out with going to D first. Okay, D first, right? Then we were in D, we went to B comfortably because there was a 0 here. From B, we had to go to C because A and D were not possible, but C was a little cheaper option. Okay, I will write down here 0. We have used 0. We have used 1. We have used 0. We have used 0, isn't it? Yes. Yes or no? Yes. Now we will try to see for another option. Okay, from A, anyways, on that path, one was there, isn't it?
Yes.
Yes. Yeah. Can I search for another option? Like first I will go to E. First I will go to E. Okay, 1. Okay. Then I'm in E now. Can I go to C? See here.
Yes.
Yeah, I can go to C. Then from C, can I go to B?
Yes.
Yes. From B, can I go to D?
Yes.
Yes. Then from D, can I come back to A?
Yes.
Here also we are having 0 zeros. Why we are giving a choice to traveling salesman is, suppose if this is the one solution, number one solution, this is second solution. Okay. In first solution, suppose the person responsible at D, okay, the person whom A has to meet, the salesman has to meet in D place, he is not there. So can't he use the second solution? Yes.
Yes.
Yes. So these two are the solutions for traveling salesman problem. Okay, in traveling salesman problem, only 5 places will be given. You can just do some trial and error, but see that you choose 0 or maybe the next best solution, that is 1 or 2, but not the expensive ones. Okay. So this is the reduced matrix where these are the reduced costs. Okay. So always to go for zeros. Always go for zeros. And I really challenge you, maybe the Hungarian method, let it be any method, any solutions we have done the assignment problem, you can't get a better solution than what we have got by using Hungarian method. Okay, so you can do some trial and error, find out some other method, other solution, but I'm sure that will be the not the best solution or what we have got by this method. So you can write down the total cost also, please, in the last. From A to D, how much do we incur? 2, isn't it? From the original matrix. From A to D, how much do we incur? 2. From D to B?
2.
2. From B to C?
5.
5. B to C, 5. From C to E?
4.
C to E, 4. From E to A back?
3.
3. Over. This is the total cost, which is incurred.
16.
Okay. Yeah, 60. Is the traveling salesman problem clear?
Yes, madam.
There is one more example given in your study material. You can also solve that. Okay. Give me just a minute, 1 minute only. Yeah. So now we'll be moving on to the game theory. Game theory is an economics concept wherein the payoffs are written in the form of a matrix. Okay. And what we have to do is we have to give to both the players an optimal solution, like what strategy they have to follow. What strategy they have to follow so that it is a win-win thing for both the players. Okay. So we can use it in the practical life. In the case of duopoly, or there, when in a particular industry there are only 2 dominating players. Okay, you have only 2 players in the market, so you will be always worried to find out what strategy do I use. Okay, what strategy? And the games which we see in the game theory are 2 versus 0 sum games. Okay, so I'll be drawing one matrix and I'll be showing what do you mean by that. Okay, yeah, matrix 1. No. Okay, so see here, there is a player A. The game theory, we talk of only 2 players. Okay, game B. Game A, we call him to be a maximizing player. Okay, what do you mean by maximizing player and minimizing player? I'll be telling you. Okay, suppose these are the numbers 20, 80, 40, 30, 50, 60. Okay, so A has got 3 strategies: A1, A2, A3. So I discussed in yesterday's class, what do you mean by strategy? Strategy can be any move which is played by this player to profit in a market condition. Okay, so it can be he can reduce the price, or he can go for advertising, or he can go for some other customer relationship management he can use, or he can use some innovation. Okay, so he has 3 strategies with him. A1, A2 and A3 strategies are there. Okay, and B company has 2 strategies. Okay, B is a minimizing player. The one who is written here is a minimizing player, and this is a maximizing player. So what I mean by maximizing and minimizing player is, how do you read this payoff matrix? Okay, let us see. Suppose if A uses A1 strategy, okay, and B uses B1 strategy. So how much is the number? A uses A1, B uses B1. What is the number given?
20.
20. So this 20 is nothing but the profit from A's point of view and loss from B's point of view. Are you getting the point? 20 is nothing but the profit from A's point of view and loss from B's point of view. Okay? And suppose A uses A2 and B uses B1. What is the number given?
40.
40 means 40. A will gain 40, B will lose 40. Okay, is it clear to everybody? It need not be that always positive numbers will be given here. Sometimes negative numbers will also be given. Okay, suppose if this is a negative number, it means that if A uses the strategy A1 and B uses B2, A's loss is 80,000, B's profit is 80,000. Negative minus of minus becomes plus for B. Okay, is that clear? Yes. Now in this case, what will be asked in the question is, we have to find out what should A use as a strategy, what should B use as a strategy. Okay, and when A uses his best strategy, B uses his best strategy. Okay, then what is the value of the game? Okay, value of the game can be 20, 80, 40, 30, 50, 60, anything, or it can be a mixture of that. Okay, so you can have pure strategy, you can have mixed strategy. Sometimes you don't have only a pure strategy. Suppose I can tell, suppose A and B, both the companies have approached me, I can tell to A, see, sometimes you use A1 and A3. I can give them that in some market conditions you can use A1, some market conditions you can use A3. I can give them the solution. In that case, it becomes a mixed strategy, mixed. Okay. So some problems, some game theory problems will have a pure strategy solution. Optimal point, we call it as saddle point. Saddle point. You can see these terms in your book. Okay, saddle point. Saddle point is where each of the players, A and B, will have a particular, only one solution. Okay, then that is known as saddle point. Okay, so now we will solve this. Okay, now I'll ask you one thing. See, my outcome is dependent on other player also. Okay, my outcome is dependent on other player. Now you think from A's point of view. You put yourself in the place of A and think. Okay, put matrix open. So 3 rows, 2 columns. Horizontal 3. Three. Looking at 20, 80, 80. Yeah. Think from A's point of view. I hope you must have copied the numbers. Okay, think from 40, 30, 40, 30, 50, 60. Think from A's point of view. If A is using A1 strategy, okay, A is using A1 strategy. The minimum assured profit is how much? 20 or 80? Minimum assured. Whatever might be used, okay, whatever strategy might be used, okay, how much minimum A will gain when he is using A1 strategy?
20.
20. So I will circle 20. A is thinking, if I am using strategy number 1, minimum assured profit is 20. So he will circle it. Okay. Then if A is using A2 strategy, what is the minimum assured profit?
30.
Very good. Circle it. See, you can't think of worst case than 30, isn't it? Yes. Can
Yes.
it happen that you can go worse than 30? No, 30 is the worst case. Okay, if he is using A3 strategy, what is the worst case?
50.
50, very good. Circle it. Okay, is it clear? Yes?
Yes.
So A, when he is using A1 strategy, so the least profit he will get is 20. If he is using A2 strategy, least profit he will get is 30. If he is using A3 strategy, least profit he'll get is 50. Now think from A's point of view, which strategy he will use? A1, A2 or A3?
A3.
Yeah, one or
A3, very good, A3. Because the least profit he'll get is 50, isn't it? Yes?
yes.
So A will be following which strategy is maximum strategy. What is the strategy name?
A3.
First we have underlined all minimums, isn't it? 20, 30, 50 we have underlined. Then maximum out of all those minimums is how much?
50.
50. So A will be following maximum strategy. Maximum. Is it clear? Now,
Yes.
shall we think from B's point of view? Yeah, now think only from B's point of view. B has how many strategies with him?
2.
2. If he is following B1 strategy, he will incur either a loss of 20 or 40 or 50. Which is the worst case?
50.
50. So put a, because we have already used circle, use square. Okay. If B is following B2, B is following B2 strategy, what is the worst case? 80, 30 or 60?
80.
80. So put a square here. Is that clear? So B, if he is following B1 strategy, his worst case is 50. Worst loss. Okay. If he is following B2 strategy, worst case is 80. Now tell me, you are B. Okay. You want a loss of 50 or loss of 80?
50 only.
Loss of 50, isn't it? So B, for B, B1, isn't it an optimal strategy? Yes.
Yes.
For B, B1 is the optimal strategy. Okay, B1 is the optimal strategy. Why? Because it is giving him lesser losses, isn't it? So B's strategy's name is minimax. What is it known as? See, first we have blocked the maximum numbers. Out of 20, 40, 50, we have blocked 50. Out of 80, 30, 60, we have blocked 80. And out of 50 and 80, which is the least, minimum out of that maximum is how much? See, those maximums were, two numbers were there, 50 and 80. Which is the minimum
50.
out of the 50 and 80? 50.
50.
So can you see here? At 50, both circle and square are there.
Yes.
That is the saddle point. That is known as what? Saddle point. So what is the optimal strategy for A?
A3.
A3. What is the optimal point for B?
B1.
B1. So A shall be using A3 strategy, B shall be using B1 strategy, and the value of the game is 50. Did you understand? Value of the game is 50. Okay. Is it clear? So this is a point where you clearly have a saddle point. You clearly have a saddle point. Shall we solve one more problem? John. Shall we solve one more problem? Then we'll see the dominance method And then we will also see some more ways. This was the case where pure strategy was there. Okay, we had a clear saddle point. There will be many games where only one strategy doesn't work out. We don't get a saddle point. Okay. Yeah, please draw 2 rows and 3 columns, please. 2 rows and 3 columns. 3 columns. Vertical columns. Vertical columns only there. Yeah. Row wise, 4, 26, 4. Pencil it. 4, 20, 6, 18, 12, 10. Yeah. X1, X2. There are 2 players. Maximizing player is X, Y1, Y2, Y3. Firm Y, company X and company Y are there. Company X has 2 strategies and company Y has 3 strategies. With it? Okay. Now tell me, for X, which is the worst case when X chooses strategy X1? 4, 20 or 6?
4.
4. Please circle it. X chooses X2, which is the worst possible case. 18
10.
profit, 12 profit or 10 profit? 10. Okay. Now tell me, out of 4 and 10, what will he choose?
10.
10.
10. He will choose 10. So he will always choose to use strategy X2. Irrespective of what Y will choose, okay, you will be getting 10 rupees of profit. Okay. Now tell me from Y's point of view, what will Y1, if Y chooses Y1, what is the worst case? Loss of 4 or loss of 18?
18.
18. So I will block it. If Y chooses Y2, loss of 20 is the worst or loss of 12 is the worst?
20.
20. If he chooses Y3, which is the worst case?
10.
10. Do we have a saddle point?
Yes.
Yes. So what is the solution? X will use which strategy?
X2.
X2. Y will use which strategy?
Y3.
Y3. Very good. Okay. Then what is the value of the game?
10.
Value of the game is 10. Okay. So yes. Is it clear? It is.
So saddle point is the max min is equal to minimax.
Yeah, if maximum is equal to minimax only, we will have a saddle point. But there will be many games where saddle point won't be there, sir.
Yeah, doesn't
Okay.
exist.
We will, yeah, so in that case, now we will learn dominance method of how to delete the weaker strategy. Okay, I'll tell you what do you mean by weaker strategies. You draw 3 by 3 matrix. 3 by 3.
3 vertical, 3.
Yeah, 3 also. Please draw 3 by 3 strategy. The players are A and B again. We will see the dominance method now. So A and B will have some stronger strategies, weaker strategies. Okay, stronger strategies and weaker strategies. So weaker strategies we can remove from the matrix. We can remove from the matrix. Okay, by following the dominance method. Okay, so we'll see dominance method. I've checked your syllabus. It was there in the study material also. Okay, please draw 3 by 3 matrix and we'll see. And in this problem, we will you don't get a saddle point. Okay. So we will see how the mixed strategy work out. 5, 20 minus 10. 5, 20 minus 10. 10, 6, 2. 20, 15, 18. 20, 15, 18. Okay. Yeah. So now you can check in your notebooks. A1, A2, A3, B1, B2, B3. You can check in your notebooks whether we have a saddle point or no. This problem doesn't have a saddle point. Okay. But what we'll do is we will reduce the matrix 3 by 3 matrix. Sometimes even bigger matrices also will be given to you. you can reduce the matrix by removing the weaker strategies. See, A has how many strategies? A has how many strategies?
3.
3. B has also 3 strategies. Okay. So see here, for A, these are profits or losses. These
Profits.
numbers are profits. Okay. So if A chooses A2, okay, so he is getting 10 rupees, isn't it? Yes.
Yes.
Which is lesser than 20?
Yes.
Yeah. And A2 strategy is giving 6, which is lesser than 15. Yes.
Yes.
And A2, if he is choosing A2 and B is choosing B3, he is getting 2 rupees, which is lesser than 18.
Yes.
Yes. So for A, isn't A2 strategy a weaker strategy? Are you getting the point? If A is using A2 strategy, irrespective of what B is choosing, he is getting all the payoffs which are lesser than 20, 15, 18, isn't it? 10 is lesser than 20, 6 is lesser than 15, 2 is lesser than 18, isn't it?
Yes.
Yes. So A won't you think A will think that why should I use A2? So he will remove that strategy. He will remove that strategy. Is that clear? It is a weaker strategy. What is it? It is a weaker strategy. You can say that, can't I compare A1 and A3 also? You can compare. See, 5 is lesser than 20. But is 20 lesser than 15?
No.
No.
No. That's why it is not that weaker strategy doesn't come into picture. We can think from B's point of view. For B, these numbers are profits or losses?
Losses.
Losses. So more losses are better or lesser losses are better?
Lesser losses.
Lesser losses are better. Okay. So you can compare B1 with B2 or B1 with B3. You can compare now. Is 5 lesser than 20? Lesser losses are better, right?
Yes.
5 is lesser than 20, but is 20 lesser than 15?
No.
No.
Yeah. Can you compare B1 and B3? Can you tell me which is a weaker strategy? See, B3 minus 10 is lesser than 5, isn't it?
Yes.
And 18 is lesser than 20?
Yes.
Yes.
Yeah. And these are losses. So which lesser losses are better always? So which losses are better?
B3.
Minus 10, 18 or 5 and 20?
B3.
B3.
B3 are better. So B1 is a weaker strategy, isn't it? Remove of B1. B1 is a weaker strategy because it is giving you more losses. Is that clear?
Yes.
Yes. So now I will draw that reduced matrix. This was the dominance method. Dominance method doesn't give you a solution on its own, but it will reduce the weaker strategies and it will simplify the problem. Okay? Is that clear? It will simplify the problem. Okay. Now I'll write down this matrix here. Now, does it have a saddle point? Please, can you tell me? Does it have a saddle point? For A1, the least is this, I will circle. Least is this, I will circle. For B, maximum is this, I will put a square. Maximum is this, I will put a square. Is there any number where both circle and square are there?
No.
No. So you don't have a saddle point. You don't have a saddle point. So we have to use mixed strategy. In mixed strategy, what you can do best is you can tell the probabilities. Okay, you can tell the probabilities. Okay, I'm writing down the matrix here again. So now what we'll do is, he must have given you a lengthier formula in your study material. Don't have to remember that formula. I will tell you how to do that. Okay, so you write down odds here. Odds. Okay, odds. Odds are nothing but the chances, probabilities. Okay, write down odds here. Okay, now the technique is, how much is the difference between 20 and minus 10? Please think well and tell me. How much?
30.
30.
30. Very good. So write down 30 on the opposite. It belongs to the first row. Write down on the second row. How much is the difference between 15 and 18?
3.
3.
3. So write down here. Okay. Write down here. Is that clear? How we have to write down? Subtract both the numbers. Write down on the opposite side. Okay. Don't bother about the minus plus sign. Only magnitude has to be taken. Okay. Now, for the first column, what is the difference? 20 and 15? 5. Write down here. Difference between minus 10 and 18?
28.
28. Very good. Write down on the opposite side. Are you getting the point? Yes?
Yes.
Yes. Now, 28 plus 5 is how much?
33.
33. 3 plus 30?
33.
33. Are you getting it? So
Yes.
it will be same. This we can do only for 2 by 2 matrix. Okay. If it is 2 by 3 matrix, we have to search for some other method. Okay. Did you understand?
Oh.
If it is reduced to 2 by 2 matrix only, we can do this method. Otherwise, we have to use graphical method or something else. Okay. Yes.
Yes.
Okay. Now, you can't talk of a pure strategy, so we can talk only of the probabilities. Okay, so I'll write down what is the probability that A will use strategy A1, strategy A2, strategy A3. Probabilities. Okay, so A has 3 choices. He can use first strategy, second strategy, or third strategy. B also can use first strategy, second strategy, third strategy. We'll write down the probabilities. See, for A1, how much is the odds here? How much is
3.
odds? 3. So your probability answer is 3 divided by 33. Are you getting the point? 3 divided by 33. Chances are there that A will use strategy A1. Is that clear?
Yes.
A2, is it there in the matrix? In the final matrix, is A2 there? So
No.
probability is
No.
0. Probability is 0. Yes? Can you tell me
Yes.
the probability of A3?
30 by 33.
30 by
Very
33.
good. 30 by 30. Did you understand? Now, if you add 3 by 33 plus 30 by 33, are you not getting 1?
Yes.
Now, tell me for B, what is the chances that he will use B1?
0.
0. Very good. What is the chance that he will use B2?
28 by 33.
Very good. 28 by 33. You people are fast learners. B3?
5 by 33.
Very good. 5 by 33. What's the sum?
1.
1. Okay. Is that clear? See, when we were doing the
Yes.
numerical where they had a pure saddle point, we told A, the player A, what strategy he has to use, B, what strategy he has to use, and also the value of the game. Okay, here also, in mixed strategy case, we talk of probabilities. What is the chance that A will use A1, A2, A3, B will use B2, B3, B2, B3, and then value of the game also. Okay, find out the value of the game. How do you find out value of the game? Take any row or column. Okay, take any row or column. Which row you want me to take? Shall I take first row?
Yes.
Yeah. So, 20
Into 3 by 33.
into 3. No, 20 into 3. 20 into 3. Yeah. First row we have taken, right? No, first column I have taken. 20 into 3 plus 15 into 30. 15 into 30 by 33. This is how we have to do. See, 20 into 3 plus 15 into 30 by 33. You can take any row, any column, and you can do, you will get same value of the game. Please. I can take minus 10 into 3 plus 18 into 30 by 33. I can take 20 into 28 minus 10 into 5 by 33. I can take 15 into 28 plus 18 into 5 by 33. I can take. Okay. Is it clear? I have taken first column 20 into 3 plus 15 into 30 by 33. How much is the value of the game? If you don't believe me, you can solve it, check it for other row or column and you can check. Are you getting the same answer or not? How much is the value of the game? 60 plus 150 by 33. 210 by 33. In the lowest terms.
Not 150, ma'am. Not 150 in the numerator. It is 450.
I'm so sorry. Yes, 450. You are right, sir. Sorry. How much is 450 plus 60?
510. 510 by 30.
510 by 33. How much is 510 by 33? I think
70 by 11.
How much?
70 by 11. 17 by 11.
17 by, no sir. Yeah, correct. 170, no?
170 by 11.
170 by 11. Is that clear? You can check it with other row or column also. You will be getting exactly the same. Okay.
Then what is the use of calculating probabilities, madam?
Probabilities, we have to tell which strategy. The solution of the game theory is we have to tell which strategy A has to use, which strategy B has to use. Okay. And if A is using the optimal strategy, B is using the optimal strategy, how much is the value of the game? That is what solution we mean by solution, sir. Okay. So now
So
this
probabilities
will give you the this probability will give the idea to A that he can use the A3 strategy more number of times. So out of 33 times, 30 times he can use that strategy. And 3 times he can use the first strategy. Okay. This value of the game is nothing but the profit which the maximizing player gets. 170 by 11 is the profit which A will get, and this is the loss which B will incur. Okay. What do you mean by value of the game is? It is the profit which the maximizing player gets. If both the players are playing the game in a fair way. Okay. So it seems easy on the exam, on the paper, solving it, but this payoff matrix is very difficult to predict. I have to first jot down my strategies and then think if I use this strategy, if other player, see, anybody who has played the game of chess will understand it more easily. Don't you think from other players' point of view? If I am using this move, other player is using this move, then what is the outcome? Okay, so we have to think from both the minds. Okay, is it clear?
Yes, madam.
Any doubts? So I don't know. Still 3 more classes are left out, I think. Tomorrow is the last class.
Maybe yesterday's class they may be giving you day after tomorrow,
Yeah.
madam.
So tomorrow and one more class only I have then in that case.
Day after tomorrow.
Yeah. So only it is the 8 classes. I don't know how the syllabus is to be done. But decision theory will be left out. Simulation is easy. You can also follow. I will share the PDF with you all, and only one numerical. If I tell you, that should be more than enough. In simulation, queuing theory is also very formula based. Okay. Then I need one complete class for simplex. Okay. I'll see what can be done. Maybe the PDF I will tell you, explain you in the PDF itself. That would be more easier, I think.
Yeah, better to explain using PDF, madam. Simplex method is very difficult.
Yes,
otherwise.
sir. Yes. I will explain you in PDF only, sir. Simulation also I'll explain you in the PDF only. Queuing theory also we'll just skim through. It is easier only, sir. Don't have to worry.
And time saving also.
Yeah, it is time saving also. Maybe tomorrow's class I'll be starting with simplex then. A simulation I can finish off in 5 minutes. Should be more than enough. Okay. Any doubts as of now? I'll ask for maybe one more class more. Okay. The rest of the subjects also will be at the same time, is it?
Same like this only, madam. Other subjects also.
On the same 8 days, you have all the subjects.
Yeah.
Okay. But all the students are working students?
Most of them are working, madam. 95%, more than 95%.
Okay. And it's a 2-year course.
Yes, madam.
Okay. This is in the 3rd semester.
Third semester.
Okay. Specialization will also be there?
Yeah. From next, only in the next semester only.
Okay.
Not from third semester.
Okay. But illustrations and all are very well explained in your material. Actually, you can go through your material thoroughly. There is no WhatsApp group formed. Otherwise, maybe the doubts clearing session could have been done on the text basis. Don't know. They haven't formed any WhatsApp group. Some other universities have WhatsApp group. I don't know. Maybe this university has some other technical reasons would have been there. Okay. If the game is reduced to 2 by 2 matrix, you can use actually this odds method. But if suppose the game is reduced to m by 2 matrix or n by 2 by n matrix, suppose if the game is reduced to something like this, you have to use graphical method. Okay. If time permits, I will be taking graphical method also.
But
Suppose
the graphical method is more lengthy than this dominance method.
Dominance method doesn't give you a solution, sir. Dominance method will reduce the problem to a simpler problem. That's all. Okay.
Yes.
Suppose if from the dominance method, the outcome is something like this. Suppose 2, 3, 5, 8, 6, 4, 2, 3. Can I use odds method? No, I can't. Such a problem can be solved by graphical. The dominance method will reduce the problem. It will not give you a solution. Please remember, dominance method will only reduce the numerical to a simpler game. Okay, but you have to use some other method to get the solution. If it is reduced to 2 by 2 matrix, you can use odds method. Okay, so if it is 5 by 2 or 6 by 2, maybe I can write m by 2 matrix, you can solve by graphical method. Okay, if it is reduced to something like this, suppose, okay, something like this, okay, 2, 4, 6, 5, 3, 9, okay, where it is 2 by